Number 97, answer the following questions. And then we have letter G. So it says that a balloon carries 40.0 gallons of liquid propane, which has a density of 0.5005 grams per liter. And then the question says, what volume of CO2 and H2O gas is produced by the combustion of this propane? Okie dokie. So the first thing I see here is that we're talking about combustion of propane, right? They told us that we had a fuel that's going to propel the balloon upward, right? It's liquid propane, and it's being combusted. It's burned in air, and here are the two products, right? Carbon dioxide and water are always the two products of a combustion reaction if you have a hydrocarbon, and propane is totally a hydrocarbon. So the first thing here is that we have to write the balanced equation. Can't do anything without it, right? Especially if they give us numbers for one compound and they're asking us to find values for other compounds. We need an equation. So just know that propane is C3H8, right? And they said it was liquid, so we could say it's L, but when I write this balanced equation, who cares about the states, right? Who cares for this part, right? So let's write it down. We're starting with that hydrocarbon, C3H8. And with combustion, remember, you're always going to be adding it with oxygen, O2, and it will yield those two products, CO2 plus H2O. Now, you could pause the video to try to balance this formula by yourself. I'm just going to run through it because we've done tons of balancing questions. So with combustion, it's easiest to start with the carbons first. I have 3, so I have only 1 here, so I'm going to put a 3 here. Go with the hydrogens next. There was 8 hydrogens on the left side. There was only 2 here, so 4 times 2 is 8. And then tally up your total oxygen. Here, I have 3 times 2, so I have a total of 6 oxygen, literally plus. I have a total of 4 oxygen here. Oh, so 6 plus 4 is 10. Thank goodness we do not need a fraction, because 2 times what will get us 10? You're absolutely correct. It is a 5. And that's our balanced equation. All right, now I'm going to write the stuff that we know. So they did tell us that we're starting off with 40 grams. Actually, what? 40 grams? 40 gallons. So I have 40.0 gallons of this stuff. That's the fuel to, propel the balloon into the atmosphere. And they gave us a density, right? Remember, gallons is a volume. And they gave us a density, so let's just write it out, right? 0.5005 grams per liter. Okie dokie. But the thing is that we need to find the volume of CO2 and H2O. So CO2, H2O, we're searching for the volumes. So I'm just going to put V over here, question mark, and volume, question mark, just to kind of give me an idea. Now, it looks like since I'm starting with volume, right, I can go to volume using my balanced equation. And we've done this in this chapter already, but there's a catch. If you want to do volume to volume conversions, you have to follow the rules of the ideal gas law, in which you can only use liters. Okay, can't really convert gallons to gallons because this is not a SI unit. It's an English unit. So the first thing we have to do is we have to convert what these gallons are into liters. And I wrote down the conversion down here, right? 1 gallon equals 3.785 liters, right? 3.7854 liters. So let's just quickly do that. We have 40.0 gallons. Converting, so all the way back to chem, the first chapter in chem. We don't want gallons, so it goes on the opposite side. In this case, it's the bottom. And we want liter, so I'm just going to put an L up here. And then according to the conversion, 1 gallon equals 3.7854 liters. The gallons cancel out, and now you're left with beautiful liters. So we're going to find out how many liters of the propane we have. So all we got to do is times 40 times 3.7854. This is not the full answer, so I'm not going to round it. So I have 551.416 liters of the propane, C3H8. So I'm just going to put that over here. So this is the same thing as 151.416 liters. Okie dokie. Now, maybe I probably need to put this somewhere. Maybe I guess we'll put it over here. I think that gives us a little bit of room. All right. Now, since we're in liters, we can use our balanced equation to convert from liter to liter. Now, this is under the impression that the pressure is the same. But remember, in the first part of this question, we did talk about that the pressure inside the balloon is the same as the pressure outside the balloon. There's no change in pressure here. So basically, since there's no change in pressure, I can just pretend that this is just going to be a mole to mole conversion, but in disguise, it's a liter to liter conversion. So let's give it to go. 151.416 liters of propane, and it doesn't matter who you go to first. Let's go to CO2. So times by that ratio, right? All we're doing is converting. Liter of C3H8, I don't want that anymore, so that goes on the bottom because I want to cancel it out. And we're going to put liter of CO2 up on the top. This is just, remember, a multiple conversion, so we're going to use our coefficients. In front of the CO2, I have 3 of them, right? So I technically would have 3 liters for every, there was no number in front of here, that just means that there was 1, right? So for every 3 liters of CO2, I just had 1 liter of the propane. So basically all we have to do is just times by 3. This would cancel, and you're left with your first answer. So that number times 3. And now I guess we can, let's see, how many sig figs? Technically, we only have 3 sig figs because of the gallons. So I'll say that this is 454 liters. All right, so 454 liters of CO2 was produced. So that's a done deal. And now we just got to do the same for the H2O. So let's go for it. 151.416 liters of the propane, C3H8, times by that ratio. Throw the unit that you don't want on the bottom. So liter of C3H8 goes on the bottom. We'll do liter of H2O on the top. Hold on. Use those coefficients. We already said that there was going to be 1 for the propane, and then there's a 4 in front of the H2O. So I'm just going to put a 4 in front of there. These units cancel, and now you have a beautiful liter of H2O. So all you got to do is multiply it by 4 now. 151.416 times 4. And I guess I'll put the answer up top here. 600... Technically, if we do this 3 sig figs, it would be 606 liters of H2O. And that's it. So there are your 2 answers. What's the volume of CO2? 454 liters. And what's the volume of H2O? 606 liters. And there you go. For everyone who's saying, we didn't use the density, we didn't need it. So sometimes, we've seen this time and time again, that sometimes they will just throw random, numbers at you, but don't be afraid to just not use it. Sometimes it happens. So in this case, we didn't even have to use the density. Maybe for the next part, I don't know why they gave it to us. I guess just to scare us, but can't scare us. We got this. Thank you so much. Like the video if this helped you out. Love helping you guys out, and I hope you guys are having a great day. I will see you in the next lesson. There's one more part, part H, so hang tight. I'll see you in a few. Bye-bye.